Welcome to Mathematics Means a Lot. In this video, we are going to see the concept of limits. Not only in mathematics, in all technical subjects, we will be dealing with lots of mathematical expression. In some mathematical expressions, if we apply particular input values, the output value will be indeterministic. In such cases, to get a deterministic value, instead of focusing on the particular input value, we will be focusing on the point very close to that input value. Let's take an example. F of x is equal to x squared minus 1 divided by x minus 1. If you put x is equal to 0, f of 0 will be minus 1 divided by minus 1, which is 1. When we apply x is equal to 1, f of 1 is going to be 1 squared minus 1 divided by 1 minus 1 equal to 0 by 0, which is indeterministic value, or we can say the function is undefined for that input value. Now, instead of worrying about the point x is equal to 1, we are going to look at the point which is close to 1, and we are going to see the corresponding output value. So let's take x is equal to 0.9. So the corresponding f of 0.9 is equal to 0.9 squared minus 1 divided by 0.9 minus 1 equal to 1.9. So I will go little closer. Let's take x is equal to 0.99. I am getting f of 0.99 is equal to 1.99. Let's go even closer. Let's take x is equal to 0.999. I am getting f of 0.999 is equal to 1.999. So if I move further, I know that I will get output is equal to 2. Now this 0.9, 0.99 and 0.999 are not only the input value closer to 1. These values we are getting by approaching from left hand side. Similarly, if we approach from right hand side, 1.1 will be near to the point x is equal to 1. So for 1.1, the output is 2.1. For 1.01, the output is 2.01. If we go further closer, the output is 2.001. So approaching on both sides, we are getting output value as 2. Now I know when x is approaching 1, my output of the function is going to be 2. Fine. Then how to represent this? Can I represent f of 1 is equal to 2? No, right? We already know that f of 1 is equal to 0 by 0, which is undefined. Then how to represent this? This can be represented as limit extends to 1 f of x equal to 2, or else limit extends to 1 the corresponding f of x, which is x squared minus 1 divided by x minus 1, is equal to 2. This means when x is approaching 1, my output is 2, not at x is equal to 1. By the understanding from this expression, I can write same thing as f of 1 minus is equal to 2. 1 minus means just before 1. Similarly, from this expression, we can write f of 1 plus is equal to 2. 1 plus is nothing but just after 1. So when we surely know the input and the corresponding output, or when it is well defined, we can write the same thing as limit extends to 1 minus f of x is equal to 2. Similarly, this one can be written as limit extends to 1 plus f of x is equal to 2. So this one is called left hand limit and this one is called right hand limit. But when we know for the valid input, if the output is undefined means we cannot write a limit directly. We have to check from left hand side and we have to check from right hand side. If both left hand limit and right hand limit are same, then only we can write a limit for the function at a particular point. So this is what called a condition for existence of limit. So in general, a function f of x is said to have a limit at a point a, then at a point a, left hand limit should be equal to right hand limit. So which is nothing but limit extends to a minus f of x is equal to limit extends to a plus f of x, and make sure that the value should be finite in value. So the same definition can be expressed in this way also. Limit h tends to 0 f of x minus h is equal to limit h tends to 0 f of x plus h. Let me show you some graphs for better understanding. So in this first graph, can you tell me, does limit exist at this point a or not? So if you see at this point, there is a gap, which means the graph is not having any value. Okay. Then we cannot write f of a is equal to some value. So to write a limit, we know that left hand limit and right hand limit should be same. Means you have to approach from left hand side and you have to approach from right hand side. Both outputs should have a same value. So as we see here, both are approaching same value. We can say that a limit exists here. Okay, fine. Now let's look at this curve and tell me, for this function at this point B, limit exists or not. So if you see here, there is a sudden rise you can observe. You cannot tell a particular output value for this input point B, right? And the condition for existence of limit is left hand limit should equal to right hand limit with a finite value, right? Okay. So if you approach from left hand side, you will end up at this output value. So if you approach from right hand side, you will end up at this value, right? So both are not same, limit not exist. Okay. You cannot write limit x tends to b f of x is equal to some value. You cannot write. Fine. Now I will ask you a final question. At this point C, limit exist or not? So take your time and come up with your answer. Hope you have some answers in your mind. So let's examine. First of all, for this point C, there is no break like here, and there is no sudden rise or fall like this also, which means the output is well defined for the input C, right? Now, so if it is well defined, we know that we can write limit x tends to c f of x is equal to some value, right? So still, as per the condition also, we need to check the limit is exist or not. We know that the condition is left hand limit is equal to right hand limit with a finite value, right? So you have to approach from left hand side and you have to approach from right hand side. So in both the cases, you will end up at a same output value, which is this one. So now you can confidently say that the limit is exists for this particular input point C, right? Fine. Hope you understand the concept of limit and its usage. Thanks for watching Mathematics Means a Lot. We will see you in the next video. Thank you.